Alright, so here is the third exponent law, power of a power. When you have a power as a base, multiply the exponents together. This is what this exponent law is going to look like. Let me give you an example. 7 to the power of 3, all to the power of 3. So this is an example of this because we have a power as a base. 7 to the power of 3 is the base of this entire power, where this 3 is the exponent. So in order to simplify this, we actually multiply those two exponents together, 3 times 3. So this would simplify to becoming 7 to the power of 9. And just in case you ever forget this, I want to show you why it's true. Let me give you a simple example. Let's do 3 to the power of 2 to the power of 3. If we were to write the expanded form of this, we know that 3 to the power of 2 becomes 3 times 3. So this is the same as 3 times 3 all to the power of 3. This exponent here is telling us we're multiplying this whole thing by itself 3 times. So let's write that out. That would become 3 times 3, that's once, times 3 times 3, that's 2 times, and times 3 times 3. Okay, so we've multiplied this base by itself 3 times. Let's take a look at how many 3's there are in total. 1, 2, 3, 4, 5, 6. So if we were to write this as a power, it would be 3 to the power of 6. So in case you ever forget it, just write out the expanded form and you can figure out that when you have a question like this, to simplify it, you actually multiply those exponents. A common mistake is to add them when you really should be multiplying. Let's quickly take a look at an example from your Powers Practice Part 3. Negative 10 to the power of 3 all to the power of 4. So you just have to remember this power of a power law. When you see something like this where there's a power to another power, we need to multiply the exponents. So the simplified version of this would be negative 10 to the power of 3 times 4, which is 12. That's it. Alright, let's take a look at the final two exponent laws. They're both pretty similar, so I'm actually just going to combine them both into one description here. Power of a product would be the fourth exponent law, and then power of a quotient is the fifth and final one. So let's take a look at what this says here. When there is a base containing multiple numbers that are being multiplied or divided within brackets, distribute the exponent to all of the numbers inside the brackets. Okay, just reading that itself is kind of confusing, so I think it'll make a lot more sense if we look at an example. 3 times 2 to the power of 4. Okay, so this is a power where this whole thing, 3 times 2, is the base, and the 4 is the exponent. So now you can see why this law applies to this question, because we have a base that contains multiple numbers, there's a 3 and a 2, and they're being multiplied together within brackets. So the rule tells us that we need to distribute the exponent to all the numbers inside the brackets. That means the expanded form of this, if we move this, distribute the 4 to both the 3 and the 2, this would become 3 to the power of 4 times 2 to the power of 4. This is what we call the expanded form of that question. Another way you could solve this problem is by using BEDMAS and actually doing 3 times 2 first, and then that would become 6 to the power of 4. Both of these are correct, but if the question is asking you to write the expanded form of the power, then you would want this as your solution. Now let's take a look at an example where the numbers within the brackets are being divided. So let's look at 8 divided by 11 all to the power of 3. So here, this whole thing is a power, and the 8 divided by 11 is our base. So we can use the power of a quotient law because we're dealing with a base that has multiple numbers that are being divided within brackets. So that means we can distribute the 3 to both the 8 and the 11. So the expanded form of this would be 8 to the power of 3 divided by 11 to the power of 3. To wrap up the video, let's take one more look at maybe a more complex question that combines both of those laws. Let's say 3 times 4 divided by 10, all to the power of 6. So the question is, what is the expanded form of this power? Well, we have a big base here. This whole thing is a base. Multiple numbers that are being multiplied and divided together. So that means we can use these laws to distribute the 6 so that it becomes the exponent for all 3 of these numbers. So the expanded form would be 3 to the power of 6 times 4 to the power of 6 divided by 10 to the power of 6. Done.